So we'll see.
I'm cool with it. That would be great.
Doesn't really look anything.
Problem 30. We probably will take one here pretty soon, though. According to a recent survey, 74% of college students own an MP3 player. It says exercise 25 to 30, write a claim as a mathematical sentence, state the null, alternative, hypothesis, and identify which represents the claim. So we're going to write a null, remember that's HO, alternative hypothesis HA. What always has to be in the null? An equal to part, and then down here's the other part, one without the equal to part. So this one, they wanted you to write it in math form first, which the only reason you're writing it in math form is so that you can write your null and alternative hypothesis. According to a recent survey, 74% of students own an MP3 player. So what's the symbol that we're dealing with? Mu, P, sigma, what? Which one is it? P.
Oh,
And is it, what'd they tell us about P?
it's equal to 74.
Equal to 74 or 0.74.
It's your claim.
So P equals 74. Is that our null or our alternative?
No.
So P equals 0.74. What else do we need to write with that?
It's also the claim.
That's the claim. Write that down. And then what do I put down here?
P is not equal to 74.
Next one.
We do 31 or like 31 through 36.
Yeah.
Not all of them, but
I
just
agree.
Pick one.
32.
Or 34 first. We'll do it. Says, write sentences describing the type 1 error, type 2 error for the hypothesis test of the indicated claim. So 34 says, a researcher claims that the proportion of adults in the United States who own a video game system is not 26. So first thing, just so that we can see what we're doing here, let's write our HO and HA. What'd they tell us? What's our letter gonna be this time, our symbol? P, M, or mu, or what? P?
Yeah.
And is it, where am I gonna write what they told us?
HA.
HA, so P is
Not equal.
to what? 0.26? That was the claim, right?
Yeah.
What's the HO then?
P is equal to 0.26.
Now, we want a type 1 error, sort of explain it. Most all these are, you could have done the same way. You should probably, and I really don't care, I told you we're not gonna deal with type 1 and type 2 errors, as long as you can sort of understand what they mean, what they're telling you. You should write it in terms of the problem, but what is a type 1 error? If we do what?
Reject knowledge, true.
Yeah, reject.
What's a type 2 error?
If we fail to reject.
Fail to-
It's false. On every one of those problems, if you just wrote those same two things, I was fine with that. Now, as we get into this chapter more and more, you've got to be able to explain what that's gonna mean. So this time it was 26% own a video game system, all right? So if I was explaining it as a type 1 error, if we made a type 1 error, then I'd say, we reject the fact that 26% own a video, and it actually ends up being 26%. And And if it was a type 2 error, I'd say we failed to reject that it was that 26% of the US owns a video game system, and it ended up being false. So we said for a type 2 error, we're saying, yeah, 26% is correct, and it ends up being not correct. But if you just wrote this on every one of those, whatever it was, 31 through 36 or whatever, that's all, just so you know what a type 1 error does, what a type 2 error does. Does that make sense? Other questions? For something like this is the reason I don't deal with type 1, type 2 errors so much. If you're doing something like the chicken that we talked about the other day, that's a big deal. Type 1 error, type 2 error. Knowing what percentage of people own a video game system, do we really care what kind of error we make? If we make an error, we make an error. We screw up, right? But it's not really going to kill anybody if we. It's important.
Maybe if you're
For sure.
working for a video game company.
Right. If you're a CEO of the company, then that's a big deal. Ryan comes in and tells you, 26% of all people own, and you find out that it's wrong,
Get a little bit upset.
then they're probably gonna be upset with you. So then when you make a type 1 or a type 2 error, because then all of a sudden, if it's a type 1 error, Brian says, yeah, 26% own a system, and we find out, and we say, no, that's not right. And we find out it's true, and we make enough systems for 40% of all the people in the world, or in the US. Now we got all these extra game systems that we wasted money on. And then we're upset because now we're losing money. And if we made a type 2 error, and Brian told us 26% own a system, and we only make enough for 26% of the people in the world, or in the US, and we sell out the first day, then we're mad because we could have made a whole lot more money and we screwed up. Other questions? Can handle all that?
Yep. Except 37.
37? All right, so type errors. If you get out the notes from last time, a lot of this is going to be adding on to that. Some of them we've already written down. I'm going to go through it real quickly. Type 1 error, you reject the HO, and it ends up being true. Type 2 error, fail to reject, and it ends up being false. We just got done talking about that. We don't need to go back over that again, do we? We went over about 5 seconds ago. So claim, it will snow 3 inches tonight. Riley comes in and he tells us, yeah, it's going to snow 3 inches tonight. No school tomorrow.
That's not much.
So our HO is 3 inches. That's our claim. That means our HA is that we don't get 3 inches. Well, if we make a type 1 error, I'm not sure why I keep
If
writing.
I'm meteorologist, we're never wrong.
If we make a type 1 error, that's when we do what? We reject this, and it ends up being true. What's going to happen if we reject that and it ends up being true?
So I'm doing half 3 inches.
All right. So, and how does that affect us?
You could be a weatherman.
You're wearing not the right clothes.
Right. Maybe you're not wearing the right clothes. Maybe you're thinking that we're going to have school today, and
I would have a stick.
we end up not having school.
Then you get to go back to the
Right? What happens if we make a type 2 error? So Riley goes home tonight, oh, we're going to have 3 inches of snow tonight. He makes a type 2 error where we accept what he's saying is true. He goes home and he stays up all night. He's got a test in prob stats tomorrow. So that's just a different kind of errors there.
Well, we would have a test prep test tomorrow because
Phoenix is gonna be this way the whole time. He's already, there's been about 10 things where he's contradicted what I've said already, and we've only been in here a couple minutes. We talked about this last time, unusual events. If it's less than or equal to 5%, that's considered unusual. Your level of significance, we talked about that, is your alpha. We're going to talk about that more today and next class.
So if we do a symbols test,
Do what?
if we do a symbols test
Remember, fish is gonna be
for alpha,
the
do you,
backwards.
do you want us to write level of significance? Okay.
Yeah, I don't want you to just write alpha. Just like,
Yeah.
I don't want you to write mu for that. It's the mean of the,
Sample.
Population.
what's the mean of the sample?
Yeah, X.
That's the one.
And what's this?
Sigma. So it's standard
Yeah,
deviation.
it's
Standard deviation
Population.
of a population.
Standard
that's
deviation.
sample.
What's that?
Variance.
Alright, so your alpha, and you'll see a whole bunch of different ones. That one looks completely different than the one, just depends where I get it from on the computer. Your alpha is your level of significance. We talked about level of significance last time. You set the level of significance at a small value, what we'll usually use, 10%, 5%, or 1%. You set it at a small value, then what we're saying is, this would be like a 10%, maybe something like this, 10%. 5% would be something more like, that's terrible, something more like this. And then a 1% would be even smaller areas out there. So 10%, there's a better chance that we're going to reject the null. 5%, smaller chance that we're going to reject it. And a 1% is even smaller chance than that. So the smaller the level of significance, less chance we're going to reject the null. Power of the test, we talked about that last time. We're not going to deal a whole lot with it, so I'm skipping over. When we're doing a statistics test, after stating the null and the alternative hypothesis, and you figure out what your level of significance is, and it says specify there, they're probably going to tell you what level of significance you want. Then the random sample is taken from population, you find all the sample statistics, or whatever sample statistic we need. You know, I'm not sure why I got X dash bar there instead of the symbol, but then you pick a statistic and we compare it to the parameter. Remember, parameter goes along with a population, statistic goes along with a sample. These are the ones that go together, we just talked about them. These tell you if, when we're doing these different things, this could be a Z or a T, like we did last chapter. For proportions, it's always a Z, and then for sigma squared or for sigma, just standard deviation, it's the chi squared. P-value, this is probably about where we left off. I'm going to tell you, we're going to write down the stuff this time and next time for p-value. Then after that, I'm going to tell you I'd rather you didn't use p-value. It's probably easier to do the way that we're going to do it. Thing that's going to be confusing today, we're going to talk about the p-value, the probability value. We're not going to learn how to find the probability value. We're just going to talk about it. Next time we'll learn how to find it. as you write this down, hopefully you're reading as you're writing it down, sort of trying to understand what it says. And I'm guessing you're probably gonna be confused. And that's why we don't wanna use p-values. I think that the other way that we're gonna use, you don't understand it, Amy? It's confusing.
Like the first half golden, no idea.
I'm gonna explain what it means, and it's hard for me to explain to you what it means also. So first thing, since it's a probability, it's gonna be a decimal or, something like 30% or something like that. That doesn't mean that we're always, P is this. It doesn't mean we're always not mu or sigma or one of those. This is just a complete separate thing. What it's saying, we take our sample and you find the mean of that sample. So we take some sample and we find the mean of it. What the p-value is the probability that the value of the mean that we found of our sample is there or farther away, lower, it could be higher also, farther away from that or more extreme than that. And the p-value is what's the probability that that's going to happen. Like what's the probability that I take Brendan's phone here in a second?
Pretty low.
100%. So p-value is just saying, if we got this for our sample, is that a good number, or what's the probability that the population sample, wherever it falls, or the population mean, sorry, wherever it falls, is within a certain range of that? Do they fall close enough together? Right? The p-value is just comparing, is it close enough to what we think the population mean is actually going to be, or is it more extreme than what we think it should be? All right? And again, I know it doesn't make a whole lot of sense now. It'll make more sense next time because we'll actually find the p-value and we'll compare it to see if what we found, the mean that we found, or the proportion that we found, or the sigma that we found, if it's more extreme or less extreme, if it falls close enough or too far away to actually be a good number for the sample or for the entire population. What we do with the p-value is we compare it to alpha, and we're going to talk about that here in a minute. This is important. This is the main thing that we're going to cover today. 3 types of tests. 3 different types of tests that we're going to deal with. One of the problems last time dealt with this, right? And we said, we don't know what that is because we hadn't covered it yet. So when you're doing these hypothesis tests, like we're going to do this whole chapter and for the rest of the year, when you're doing these hypothesis tests, there's a left-tailed test, a right-tailed test, and a two-tailed test.
Let's go back to 2 home proofs.
This here is important, and I think, and I'm gonna try to find my paper here in a second to make sure, but I think this is sort of all on your charts, on one of the pages of the charts, and we're gonna use the charts. You might want to find your chart, because I screwed them up a couple years ago, and I think I fixed it, but I don't remember if I gave you the correct one or not. That's the right chart, but I'm gonna tell you what page to turn to, and there's something written on that page,
Yeah.
and I gotta know whether,
Well, on the front page, it has that 10.
that's something that we're gonna use,
Alright.
so that's one of the things, yes. We're not gonna use it today. So on your charts, like Daniel's saying, this front thing right here says L, R, and 2. Guess what L stands for?
Left.
Left. R stands for right. And then 2 stands for two-tailed. Alright, so we got a left-tailed, right-tailed, a two-tailed. We're not going to deal with that. That tells you the z-scores if you're given a certain alpha. That's going to be what we're going to do later on, next time after that. This is going to be the way I think that you're going to like it better than dealing with the p-value. If you turn to table 5, the t-distribution table. At the top of the t-distribution table. You see where it says left-tailed? And above it, it's got HA. It should have, looks like, does it look like I whited yours out or something? It should have HA is less than with that alligator mouth. So make sure, is that the chart that I passed out to everybody? Yeah. Alright, so you're always looking at the alternative hypothesis to figure out whether you're left-tailed, right-tailed, or two-tailed. Okay? So HA is less than, that's a left-tailed test. HA is greater than, that's a right-tailed test. And if your HA is not equal to, then that's a two-tailed test. Flip over to the back of that page. It's got the chi-squared. And at the top, it should say the same thing. If HA is less than, it's left-tailed. If HA is greater than, it's right-tailed. If HA is not equal to, then it's two-tailed. Is that what everybody says?
Yeah.
Flip back to the T-chart. Sorry, I forgot something on the T-chart. We did level of confidence, that first row going across the top there. We did that earlier in the last chapter. Notice right below that, what's it got? One-tailed and two-tailed. We're going to use that this chapter. All right, now flip again to this. This is the exact same chart that's on the front page. So I put it on the front, I wrote it on the front here, just so that you wouldn't have to flip back through to find it here. So it's right on the front. That's the exact same chart as this little chart that I wrote on the front. Flip that page over find this, we're gonna use this today.
So that chart that you said we're using today, is this does this also like, so would the p-value, if we were to use p-value, would that be like the evidence that they're talking about that supports the claim?
Right, what this is, remember I said, start of last class, that you guys are gonna hate it because you have to write this stuff out, and you have to, this is like the start of writing it out. So each time, your sentence is gonna start, there is enough evidence to, it's gonna be one of those 4 boxes right there that we're gonna start our stuff with every time. All right? And we'll talk about that as we go throughout the rest of it. Remember I threw that there. So that's left-tailed. Now, what the p-value is, to try to explain this a little better, and again, we're not going to find the p-value this time, but if the p-value falls in here, then that means the p-value is more extreme than what we think it ought to be. All right, so if it falls in that shaded part there, then it's more extreme. And to do that, all we're going to do, and this just goes through each of the tails like we just did. That's a right tailed, and then with the not equal to sign is a two-tailed. So if the p-value falls in either one of those, then we would go with that. So all this says exactly what we just said last time and everything. Whether to reject or fail to reject the HO, we're looking at the p-value. Again, we're not finding the p-value. I'm skipping through this. We're going to talk about all this next time. We talked about these last time also. This I would write down. If we're doing the p-value stuff, that's what we're using. So if we find our p-value and we know our alpha, if the p-value is less than or equal to alpha, then we reject the null. If the p-value is greater than alpha, then we fail to reject the null. And again, this might not make a whole lot of sense to a lot of you. We're not going to find the p-values today. We're going to hold that off till next class. When we start finding them, then it'll make more sense. But just knowing p-values less than or equal to alpha, you reject the null. If it's greater than alpha, then you fail to reject. No matter what we do, can we ever say that the null statement is a true statement? No. If we want to say something is a true statement, then we have to make it our alternative hypothesis. Hold on, Brian, don't talk to your folks. So if we want to prove something is true, then we want to set it up to be the alternative hypothesis, not the null hypothesis. Because the best that we can ever say about the null hypothesis is that we failed to reject it. So we're not saying it's true, we're just saying we can't say that it's not true. Again, our alphas, when we do find the p-values next time, you're going to compare it to your alpha, whatever alpha they give you. We said we're going to use alpha as what? What were the three alphas that we're going to use? Nobody remembers? What three alphas are we going to use? 10, 0.05,
And 1.
0.01. So 10%, 5%, and 1%. And we're going to find a p-value, and we're just going to compare it to one of those three most all the time. All right? So if we pick a 10% alpha level significance, and we come up with a p-value to be like 0.09, we say, okay, 0.09 is less than 0.10. Well, if it's less than that, if this is our p over here and it's less than that, do we reject the null or fail to reject the null? If our p-value is smaller than our alpha, do we reject or fail to reject? We reject it.
Less than or.
So you make a decision based on the thing. This is on your chart there. And this is what we're going to, the main thing that we're going to learn to do today. You're going to learn to start these sentences off. All right? When you start these sentences off, this is what you're going to start them with. One of those four. So that's on your chart. You don't have to rewrite this down. I put it on the chart there. You're just going to have to flip back to this every single time that we're doing one of these problems. And as we go throughout this chapter, we're going to add stuff to this. So you're going to write this big long sentence. And I feel sorry for you. Not really being sarcastic here. You're going to write a sentence and it's going to say, there is enough evidence to reject the claim that the prob stats class will enjoy writing the conclusions for each of these statistical hypotheses problems that we're going to do. And that's what you're going to have to write out. The good thing about it is, they tell you this, and the second part of the sentence and the third part of the sentence is going to be this, sort of the same thing every single time. I shouldn't say that. It's going to look the same just about every single time. But one time it's going to talk about Jackie, next time it's going to talk about Mackenzie as we're writing it out. All right? You perform a hypothesis test on the following claim. How should you interpret your decision if you reject the HO? And how should you, if you fail to reject? This is exactly what the assignment looks like. A university publicizes that the proportion of its students who graduate in 4 years is 82%. First thing you should do, write the HO and write the HA. What's the HO this time? Or the HA? Which one you want to write first? What's this tell us?
P is 0.82.
So since it's a percentage, it's P. And is means what? Equals 0.82. That's our claim. Make sure you label your claim. What's your HA going to be then? Now, grab your packet and look at this page. This says you reject the HO. So that's the first thing that we're gonna answer. You reject the HO. And I'm not gonna write all this down, I'm just gonna talk about it. All right, so listen closely. If we reject the HO, you look on this chart, it says right there, you reject HO. And then we look to see which of these four we want. Was the HO the claim? Yeah. So guess what box we're gonna start our sentence with? That first one right there. So what we're gonna say, there is enough evidence to reject the claim that, and then we go back to the problem, that the university students, or that 82%, sorry, I'm not very good at this because I'm terrible at English, that 82% of the university students graduate in 4 years. That's what we write. Now, what if we fail to reject? We go to this column or this row going across here where it says fail to reject, and was the claim the HO or the HA? The HO. So we look right here, and what we start off our conclusion or our statement with here is there is not enough evidence to reject the claim that 82% of the university students will graduate in 4 years. So we find the statement on here that fits for what we got, whether we're rejecting or fail to reject, and we connect it to the problem. It's not too difficult, right? So there is sufficient evidence to indicate that the university's claim is false. That's sort of what we said. Fail to reject, there is insufficient evidence to, they put some big words in there that I didn't put in on my little chart here. So on and so on. Do this. What you're going to do each time. First thing you got to do, and these boxes are supposed to be up there again. Another one of those things that I tried to move and it won't. First thing you're going to do, write your HO and HA every single time. Second thing, specify your level of significance. They're probably going to tell you that. Third thing, you're going to draw this little graph, like I said that you should have been drawing most all the year. We're going to draw this, and we'll either do something like this, we'll have this shaded in, or some other part shaded in, or whatever. We're not going to do that part today. And then your fourth thing is you're going to calculate your test statistic and see where it falls on the sketch, on the graph. If we're doing a p-value, that's going to be done one way. The other way that we're going to do it is the way that I'm explaining here, sort of. We're going to see if it falls in that shaded region. It really doesn't matter which way you do it. I just think that the shaded way is better. And again, that makes no sense to you because we haven't talked about it yet, but we will. Main thing here, state your HO and HA, figure out your level of significance. You might want to put down here, use the chart. When you go to write out your final sentence, your final statement, you want to use this chart.
Yeah, I can see it.
Figure it out.
You need to get a little closer.
Yeah, some of them. No, move.
Roll it up and get it a little
Oh, yeah,
closer.
that's what I'm telling. You know, if you really hit me on the head with that, I'm sure to mistake. Where's that block though?
What?
He said it'd stay in his brain if I hit him.
Yeah. That's safe.
Yeah, you're not cool like me.
I got, look my shapes.
You got a cone?
Give me my comb back.
This my cone.
Get it, Mr. Ebersole.
This is my cone.
It's not your cone. Give me some milk block.
Riley,
No,
Trade. It was just like, I got trade.
okay, you triangles.
No, I want my cone.
Hey, we might be short, but at least we're allowed to have fun at school.
I'll change
This
this.
is how we have fun at school.
I want that quality
Yes.
It's 7 hours.
Acting like you're 10 years younger than you actually are.
Hey, it's like,
What do you think of
This
our
is
vice
a
president?
you should fight him.
I know, I want the cone.
I can't.
Oh, yeah. I also got.
If I keep trading you
I mean, it could, it would be a check.
Yeah, but I need like building blocks.
I got a hologram.
Well, she was telling me that
Listen,
they just fight.
you have so much in your bag, dude. This is my entire inventory. That's so much better than this.
Maybe because it was
That's because the people who sat in your seat back here like to throw them at each other.
Yeah,
They throw away.
Speaking of which, make sure there's none laying on the ground.
Put an orbit thing.
Yeah, I know, that's nice of people to throw their trash in the back.
Yeah, there's more orbit.
I got a lot of trash.
Whoever sits here to choose orbit goes.
The people here like to throw
I got a
away.
protractor.
I got a phone.
Yeah, who needs 2 protractors?
So this is all that stuff. Now, before you start to write this down, I probably wouldn't write it down. Again, notice, this is if we're using what? The p-value. Again, next class I'm going to highly suggest that we don't use, we're going to use it next class, and after that, probably not. Alright? So, if we're going to use the p-value, then use that. You write your statement to interpret. Here, I've been trying to figure out interpret that word the whole class. Did you notice that, Daniel? You see that I couldn't, every time I stopped, what am I trying to say? And I couldn't think of the word interpret. So when we go to interpret it, you're going to use this chart. I wouldn't worry about this too much because again, I don't know p-values. Some students think p-values are a whole lot easier. I just rather teach it one way because that seems less confusing to a lot of people.
Brendan stole it. I would offer. The best I can do. You said things in 3D. I didn't know that.
Imagine that. I'm gonna go with 3D edition.
Oh no, it was in the endless bag, but whatever. I can't find the key value. Very distracting. If I knew what it was about.
Didn't I tell you?
Deal.
This hurts my eyes.
I got scammed. Do you see that? He traded me a broken foot for his protractor back. I'll trade.
I'm changing this protractor.
I want you stole from me. You stole from me.
That's the assignment. You might want to get your books out and we'll do a couple of problems just to do a couple of examples. I'm going to start. If you guys start talking, I'm going to go sit down. So Sean already said he wanted me to sit down and not do anything for you. So if he starts talking just to be a jerk to everybody.
As long as it's real, I can take it or leave it, but I do appreciate it.
37 says state the null and alternative hypothesis in words and then symbols. I just want symbols, I don't care about the words. Then determine whether the hypothesis test is left-tailed, right-tailed, two-tailed. Explain your reasoning. I really don't care about explaining the reasoning. You can explain it to me while we do it. All right? So we know we're going to state an HO and an HA. Guess what we're gonna do just about every problem from here on out for the rest of this chapter. HOHA. At least 14% of all homeowners have a home security alarm. At least 14% of all homeowners have a home security alarm.
So 14% or less.
So, what symbol are we using first of all? P. So we know it's gonna be a P. At least 14%. What's that mean?
Is that greater than
There's
8?
14% or more.
So 14% or more, so,
If we have metal.
so, what is it? Is it less than or equal to, greater than or equal to?
Less than.
Greater than, equal to, what goes here?
24.
And that's our claim. What's gonna be our alternative hypothesis then?
P is less than 0.14.
Now, we wanna decide, we're looking at our little graph here. We wanna decide whether it's left-tailed, right-tailed, or two-tailed. What do we look at?
The alternate.
What is it? Look back at your chart, what that chart tells us, if it's got that less than symbol in it. Left-tailed, that's answer 37.
Left key.
Where are we going to next?
57.
57?
Usually put the hard ones at the end. It's true, actually.
Does everybody have that one so I can erase it?
Right.
57. Says, in exercises 57 through 60, you are given a null hypothesis and 3 confidence intervals. Does everybody remember what a confidence interval is? From last chapter, we 95% confident that it's gonna fall in here or whatever. So those 3 A, B, C over there at the side of those. Decide whether each confidence interval indicates you should reject the null, or they didn't write it, but they should have. Either reject the null or fail to reject the null. So that's what we're gonna put on each one. Either we reject the null or we fail to reject. So we look at 57. Says our null hypothesis is mu is greater than or equal to 70. So A. Should we reject or fail to reject the null?
Fail to reject it, right?
Fail to reject it. How come?
Because the arrow goes in the wrong direction. Because it still goes through 70.
Yeah, but it's mu greater than or equal to.
So is, if we look at our confidence interval, is some of our null hypothesis in that confidence interval? Yeah, so what's that tell us to do? Right, so we fail to reject the null. Letter B. What do we do there? How come?
Because it doesn't go through 7.
So the confidence interval is from 67 to 69. None of that falls in our null hypothesis, so we reject the null. Letter C. What do we do there? Fail to reject it again. Because some of it falls in there, right?
Yeah.
Next one.
Let's do 58 over here.
Do 58 while we're there?
Yeah.
How about A?
Fail to reject.
Fail to reject, how come?
Because the 54 fits in there.
Alright, it's got a little bit of it in there, right? So fail to reject the null. And I try during this chapter, I try not to get lazy. This stuff should be written out. You'll probably see me at some point where I will get lazy and do the Charlie Brown, right, and do stuff like that. B.
Fail again or reject, fail to reject.
Wrong problem. Fail to reject again?
Yeah.
The last one's reject.
Last one's reject, everybody agree with that?
Can we do 43?
43? So everybody got that much?
Yeah.
Yeah. 43 says, interpreting a decision. In exercises 43 through 48, consider each claim. If a hypothesis test is performed, how should you interpret a decision that A, rejects the null, B, fails to reject the null? So 43 says swans. A scientist claims that the mean incubation period for swan eggs is less than 40 days. First thing, every single time. Every single time, H-O, H-A, before we start to actually write our interpretation of it. So this scientist says incubation period is less than 40 days. Is that going to be our H-O or H-A? H-A. Since we're saying incubation period, are we using mu, P, sigma, what? Mu. So mu is what? Less than
40 days.
40. What's our HO going to be? Oh, I'm sorry, what did I forget there?
Claim.
That's the claim. What's our HA going to be?
Mu is greater than or equal to 40.
Do I?
You said HA the second time.
Did I say HA up here? Sorry. That's your HO. Sorry, I messed up.
I'm sorry, I just was confused for a second. I'm
Okay.
sorry.
So part A says, you reject the null hypothesis. So we grab our chart. I don't have my chart. I don't remember what I did with it. I threw it somewhere else now. I think it's behind you now. I moved it. That's all right. You can look at it. You guys can help me. So you're on your chart. Is our claim our HO or our HA? HA, so we find that. And the first part, part A, says we reject the null. So what's our start of our sentence going to be?
There is enough evidence to.
There is enough evidence to what? Be careful now. To support the claim, is that what it is?
Yeah.
Make sure, all right, because there's only like one word difference in a whole bunch of these, right? So you got to make sure evidence to support the claim that what?
The mean incubation period is 40 days.
That the mean, and I should put mean in there. Mean incubation period
Less than 40 days.
is less than 40 days. I don't know if I'm gonna be able to handle it. I'm already getting tired of.
Yeah, I don't like it. We're writing books now.
See, I don't mind if you guys have to do it. It's when I have to do it. It sucks. So what's B? B is if we fail to reject the null.
There is not enough evidence to support the claims.
There is not enough evidence to support, notice Brendan, no, I haven't given out yet, the claim that, what?
You're doing good. Okay.
Mean incubation, even though my writing's starting to look like Brian's.
No, you're just writing in cursive.
Incubation period is less than 40 days, is that right?
Yeah, I'm kind of grading this one. Like chickens.
Yeah, Brian's gonna have to write neat this time because the chicken scratch, this is what Ebersole does. I can read this, so if it's no worse than this right here, it's all right. But if it's your, Brian, if it's your normal writing, that, who grades it?
You're gonna be able
No,
to
you don't
read
grade
two
it.
words out of mine.
So-
Not and there is.
So watch, this is what happens if you write like you normally write, Brian.
I was embarrassed when he had to write on my
That's pretty bad, isn't it?
In anatomy, when we had to switch papers, I was embarrassed.